Okay, so we're going to solve the second part of this question now. We have the wire, and we're looking to work out what t is in this circumstance here. So we originally, with the first question, explained it in terms of the principal moments, but we're going to look now at the tension, calculating the tension on the wire in this situation here. So here we're asked to calculate the tension T in the wire, and we're asked to calculate it in newtons. Okay, so let's have a quick look at how we're going to do this on another sheet of paper. So I'm just going to draw out the situation again real quick. I'm not going to be beautiful, but we'll just have a good... So we've got the sine, and we've got 120 newtons there. Not that that's really relevant for this question, but that's okay, I'll draw it anyway. We decided that from last time we had a vertical force of 60 newtons, and obviously we've got our angle theta, and we'll talk more about the symbols and what we use for theta, or why we use theta later. So that's 30 degrees there, and we're asked to work out what the tension is in that wire there. So let's have a look at how we do this. Well, this is a vector resolution problem. Now, one of the most difficult aspects of these kind of questions is identifying, in terms of the trigonometry of the question, just what is the hypotenuse, the opposite, and the adjacent. Now, it can be difficult in some of these situations, but you just have to pick it apart and just say, okay, well, what is what? Okay, so here we have a situation where we've got the tension pulling in that direction. In this case, this tension is creating a vertical and a horizontal pull. Imagine pulling down on a wire diagonally downwards. I can draw that picture up here. So imagine I'm a person and I pull diagonally downwards on a wire. You can hopefully see quite clearly that I am pulling it in that direction, and I'm also pulling it down. This force here that I'm exerting is creating those, so a vector triangle of that situation would be that. And if we give these letters just to show you what I'm meaning here, so we've got A, B, and C, so we've got B, A, and C. So hopefully that makes sense, and you can see how a force can create a vertical and a horizontal component, as we're doing here. So let's have a look at this situation then. Well, quite nicely, this is very similar, just the other way around to the diagram I just drew up here. This tension is creating a vertical force and a horizontal. So I'm going to draw the vector triangle separately over here, just to make it nice and clear. So I've got tension there. I've got my vertical force there, which is my 60 newtons. And I've got my T, what I want to find out. So now we can complete the triangle quite nicely. Now, we know from the diagram that this angle here is 30 degrees to a right angle. So you could potentially work out just what that angle is. Now, I'm not going to do that because that's extra math and nobody likes to do extra math. What we can do is we can just say that that angle there is also 30 degrees by using geometry. You're not going to get the answer wrong if you do take 30 from 90 and you get your 60 and you're thinking, okay, well, where do I go from there? You just need to approach it in a different situation. You'll need to identify what the different sides are. I might do it again just to show you the other way of doing this, but this way works quite nicely. So let's identify the sides. So we've got the hypotenuse, the adjacent, and the opposite. Now we've got the opposite, so we're happy about that one. This is the one we want to find out. So we are going to apply some GCSE maths. So Toa. Well, we've got the opposite and the hypotenuse. So yes, we're going to be using sine equals opposite over the hypotenuse, and that equation will form up quite nicely like this below. So we're going to go sine theta equals the opposite over the hypotenuse. At this stage we need to do a little bit of rearrangement because we want to find out the hypotenuse. So, quick bit of rearrangement, opposite over sine theta equals hypotenuse. Obviously, I've skipped a couple of steps in the algebra here. What I will do is I'll make another video to show you how this algebra works, but for now we can actually just quite nicely show that this is a shortcut step for the algebra, that the opposite goes over sine theta to give the hypotenuse here. We'll do the algebra later for that, not now though. So, we know the opposite is 60 newtons, apologies, over sine 30 degrees. And all we need to do there is plumb those numbers into our calculator. So we've got 60 divided by sine 30. Now, the reason I'm showing you what I'm doing on my calculator is actually quite important, because a lot of students struggle with using a calculator. I know that might sound silly at first, but when you get into more advanced algebra and the way you're actually calculating these things, it's important to see what's actually going on the calculator and how I do it to try and make it a bit easier for you. But anyway, that one's a nice easy one, and that's going to give us 120 newtons. And that is our answer.